Jesse, do you know how to work the Bernoulli equation?
Nuh-uh, man. Do you?
No? When's our fluids final?
I think it's tomorrow.
Holy crap, dude. I don't know how to do this. This is like the biggest part.
I know, man.
I'm going to go talk to Dr. Bruce.
Today we're going to show the effects of velocity with height. Here we have a hole that is 0.25 meters from the top of the water. When I release the valve, then it's going to release the water at a velocity of 2.2 meters per second.
We can see from our diagram that 1 and 2 are both exposed to the atmosphere. Based on the Bernoulli equation, then P1 and P2 go to 0. V1 can be assumed to be very, very slow, much less than V2, so it can go to 0. So V2 becomes the square root of 2gh, which is our 0.24 meters. So V2 equals 2.2 meters per second, with a height difference from 1 to 2 of 0.24
now
meters.
We're going to show a hole that is a height difference of 0.1 meters. This here now makes the velocity 1.4 meters per second.
As you can see in the video, velocity in hole 2 is always greater than the velocity in hole 3. Applying the Bernoulli from 1 to 3, it reduces to the same equation. V3 equals 1.4 meters with a height change of 0.1 meters. Based on this equation, we can predict the height change for any system where the constraints are the same, where 1 and 2 or 1 and 3 are both exposed to the atmosphere, and the diameter of 1 is much, much greater than the diameter of 2. The Bernoulli equation can also be used to show how the change in velocity between two objects, like these two Coke cans, affects the pressure. When we blow in between the two Coke cans, against what you would think would happen, the two cans go together. Using the Bernoulli equation, we can prove that velocity is inverse to pressure. Increase the velocity between the two cans, the pressure drops. As the pressure drops, the cans are drawn together by the vacuum. Whew. Okay, I'm good. Dr. Bruce showed me how to use this amazing Bernoulli equation and all what it can do. It can relate pressure and velocity, if they're inverse to each other, and we can relate the velocity of outflow and with the height of the fluid. I'm ready for the final.